Hi everyone. Thank you so much for joining today's session, where you'll be getting a preview of what a day in a life of a data scientist looks like. So, today I'll be going over some very important topics and some concepts that a data scientist will have to use at some point. Um, just to introduce myself, my name is Anchal. I am working as a senior data scientist in the Insights and Data team at Capgemini Middle East. I'm based out of Dubai. So my work mainly involves engaging with different clients here in the region and delivering data science and AI projects. Apart from my job, I'm also part of different communities like the Women in Data Science, where I'm a co-ambassador and I've organized regional events here in the UAE. So that was about me. So now let's get the session started. So before actually going over the content, I just wanted to say that feel free to ask any questions you have. If you feel the need, you can always um, text in the chat box, and there will be a separate Q&A session at the end where I'll be addressing all the questions, and you can also speak up if you like. So let's go over the agenda. So what we'll be covering today. So uh, at the first, I'll be going over the basics like what is data science, why is data so important in data science, some of the methodology that is there. That you use in any data science project, and also some tools and technologies that you can use to complete any data science project. Then I'll be also going over some ML concepts, like some algorithms that are most commonly used, and we'll also look at what is MLOps and explainable AI. And then I'll be ending it with some concluding thoughts and how you can actually build a career in data science. So, okay. So most of you already are aware that data scientist is one of the hottest profession of the 21st century. Everyone these days are quickly learning online and quickly acquiring these skills so they can be attractive to potential recruiters. On the other hand, there are different organizations that are very excited to use data science for their business problems, even though a simple program can sometimes solve their job, but they're most excited to use data science to solve their business problems. So there are many misconceptions, like as such, that I just said, like, you could always use a simple program to address your need. So although it may seem that data scientist is a very glamorous job because you get to play with different algorithms, there's a lot of prediction going on, but most often the word data in data science is always disregarded, and this actually makes a huge difference. Data makes a huge difference when you're applying data science. So what is data? Uh, right now I would like to engage the audience here to tell me, what does data mean to them in simple terms. You can use the chat box, or you can even speak up. You can use one word, or you can say a sentence as you like. So I'm just going to open the chat box as well, just to see. Anyone?
Yeah, exactly. Yes.
Okay, yes, information that can be used. That's correct. Okay, everything. Yes, data is everywhere. You're absolutely right. So getting insight from data. Okay. Yep, that is data science. So okay. So when we say data, it can be anything, right? As you mentioned, Abdullah, it can be everything. It can be numbers, words, sentences, images, audios, whatever you can think of. Like let's say for a retailer, data would mean the different transactions that are conducted by their customers. For a bank, it would mean something else. Like, for example, if they are providing a loan, they need to collect data about the loan itself. And even right now, like this session is being recorded, right? Even we're creating data right now. Data is being created every minute, every second. So there are actually, just 1 second, just closing this chat box. So there are two different kinds of data, and you might have heard of this as well: structured and unstructured data. So as the name suggests, and also like as you can see from the slide as well, structured data is highly specific, and it's actually stored in a predefined format. If I were to give an example, like let's say you go to a school and a student's information is actually stored in a very specific format, like their name, their age, their gender, all of this would be stored in a table in some database somewhere. But when it comes to unstructured, as the name suggests, there's no predefined data model here. It's not really organized really well. So if I have to give an example, this can be social media data. It's coming in from everywhere. There's no particular format. You could be getting images, videos. So these are actually unstructured data that is usually there's no format for this, and it usually you use data lakes to actually store this kind of information as well. And all of this information can actually be retrieved in real time, like at the minute itself, or it can be processed in a batch. So batch is basically like at the end of the day, you have some data, you're processing it all together. Real time is basically you're getting it every second, every minute. Yeah, so that actually brings me to the next subject. What is data science? And so according to you, what do you think data science is? I'm sure everyone here has an idea, has a heard of data science. So what do you think? You can give one word or anything, basically. You can use the chat window.
I would
So
just
I've
ask
already
you,
gotten an answer from before, like getting insights from data. That is one. Okay, it's a process or method to convert unstructured data into structured. Okay, yeah, that is one definition, getting insights. Yes. Yes, so you've already answered getting insights, right? Data science is actually the process of managing all this data, converting it into something that can give useful results, that can result in new discovery. It can provide insights and innovation. Is basically a combination of data collection, preparation, building models, and etc. And I would be going over this entire pipeline in further details as well. So uh, So if you look at this slide right now, you would actually be seeing a lot of buzzwords. You're seeing AI, you're seeing machine learning, deep learning, data science. All of these are buzzwords, and you all might be thinking that all of these mean the same thing. But this is the difference here, this Venn diagram. So you see AI, machine learning, and deep learning are all part of data science. Why is that? It's because all of these are actually using AI to, they all of them are using data to perform their job. So if we look at AI is basically means implementation of different models that would be predicting future events. Whereas machine learning is more of a subdomain of AI, where it's actually using data to identify different patterns to help forecast, and it uses algorithms like random forest to do that. Deep learning is more of an advanced technique where you for prediction, which actually makes use of artificial neurons to do the same. So usually they call a data scientist a magician who does all of this magic, right? But so they're also known as someone who wears many hats, the hat of a statistician, programmer, business expert. So when we say statistician, a data scientist is someone who needs to have some statistics knowledge as well. That means they need to understand the results. They need to be able to fine tune, and that is why they need some statistics knowledge as well. A data scientist also needs to have some programming skills. So they need to know at least Python or R to actually be able to code the models that are there. They also need to be a business expert in the domain they're working in. So like, for example, if I'm working in the banking sector, and if I don't know how loans are processed, or how a credit card is issued, the basic knowledge itself, I wouldn't really be able to evaluate the models that I'll be building. I wouldn't really be able to know that if the quality of the data that is coming in is correct, and also so there would be all sorts of these problems. I wouldn't even be able to understand the business problem in the first place. So that is the reason why a data scientist also needs to be a business expert in the domain that they're actually working in. So now I would actually be going over the data science methodology, the entire start to end, how the journey that it takes to actually reach the end and get a model. So so you first would start by understanding the business problem. You would be speaking with different stakeholders and trying to see what kind of business goals that the business has, trying to understand what the problem is basically. And then once that is defined, you will start by collecting external data. Like, so data could be coming in from surveys, it could be coming in from different customers from different databases, which all needs to be collected in one place so that it can be processed and then sent for cleansing and preparation. So data cleansing is actually a big part of this process. Data has to be cleaned properly. Data quality needs to be increased before you can actually move on to building the models. So the next process after cleansing your data would be to analyze the data that is there. So this could actually mean building any dashboards, finding any hidden insights that are there, and actually presenting the exploration that you've done to any key stakeholders at this point as well. The next step would be building a model. So at this point, once you have your data ready, you have already understood the business problem, you would want to define what kind of model I would need, what kind of, like for example, if you already have a model in place, you wouldn't want to set any learning parameters for this model, and then move on to training the model with data that you have and the model that you'll be using. Then you would be testing your model. So you would be keeping aside some test data to actually test your model. And then you would be moving on to the evaluation. So evaluation would mean you can actually use different kinds of processes. Like, for example, you can use a gain chart to do your evaluation, and there will be other techniques as well that you can use. And at this step, if your model doesn't give the right results, if it doesn't give the right accuracy, it's not giving the right gain that you need from the model, you would actually need to move back. So you would be moving back to the data processing, because you know that there would be some problem in collecting the data in the first place, or there was a problem in choosing the model and choosing the learning parameters in the first place. And then the entire cycle would go again, where you would start by cleansing the data, building the model, training it, and then testing it, and going back again to evaluation. So if you at this point realize that, okay, my model has given the right results, and I would want to move to the next step. Next step would be to see if the model that you've built is giving the right business outcomes. Is the problem that was defined in the first place, is it actually performing accordingly? Is it fulfilling the goals that were defined initially? If no, then you obviously know there was a problem in defining the business problem in the first place, and you need to start all over again to define the goals, the objectives again. And if you realize that, okay, my model has given the right results, you would be moving on to deploying the application. So if you are deploying it onto web, you would be deploying it onto your website or your mobiles, anywhere. And then the last step, mostly this is maintenance, so it's like a continuous cycle, and this where MLOps come in, which I would be speaking about ahead. So you've seen the entire cycle that a data scientist has to go through. So there are many tools that a data scientist can use at every stage, or they can even go for even one single tool and do the entire job with the same tool. So usually a data scientist prefers using Python for most of their tasks because it solves mostly everything. You can build a model, do your visualizations, data cleansing, and everything. Another language that's also used is R. So R is another option that you have, but mostly people actually use it for data visualization. You can use it to build models as well, but visualization is the one people usually go for. You can also build Shiny apps using R for POC purposes, or other purposes as well, if you like. Jupyter Notebooks is actually a web-based IDE, so you can actually code in Python or Scala and on that platform. TensorFlow is actually a Python-based library, so it's open source by Google. You can, if you want to build any deep learning models, you can use the TensorFlow library for that. Hadoop is actually used when there's big data involved. Big data is when you actually want to store huge amounts of data, and then Apache Spark is used is actually the data processing framework that you use on big data. SPSS actually does all of your jobs. Like, you don't need to, if you don't want to code, you cannot go for SPSS. It's actually a drag and drop tool, and you can do the end-to-end process just by using drag and drop, the drag and drop modules that are there. Git, so I'm sure some of you might have heard of GitHub. So Git actually does the same job. You can keep track of your changes in the code when you're working with a large team. And the last one, so I'm sure some of you might be surprised to see Excel on the list. So actually Excel is one of the most common tools, because what would happen most of the time is that you would be seeing a lot of files coming in that are actually Excel files. So you can actually use Excel to make small changes in the data, like replacing any words, finding any key terms, or even using the Excel formulas that are there, like sum, average, and to do any kind of job that is there. So these are the different tools that you can use if you want full control over what you're doing with every single step. But if you are working as a citizen data scientist, you can always make use of low-code data science tools. So low-code data science means that you actually use a cloud provider like Azure or IBM, AWS, which have their own AI toolings to resolve many AI problems that are there. For example, you can use the cognitive services that are there, like image recognition to classify any images that are there just by dragging and dropping. NLP, again, you can use drag and drop to do the same task that you would if you would have used Python, but you would have to code the entire model yourself. So these tools actually make use of, so these cloud providers actually make use of drag and drop tools. You can also use Jupyter notebooks as well on them, but drag and drop is mainly used if you are a citizen data scientist. Enterprises also use them just to quickly evaluate their business problems and build any POCs if they have, or if they want to quickly want to come up with a solution without spending a lot of time. Sometimes privacy can be a concern when you're using cloud, but then that's another topic to be discussed. So you can apply data science in any industry that uses data, right? So, and almost every industry that you see is actually using data or is actually creating data. So if you look at the banking sector, they're collecting a lot of data around their customers, around loans, credit cards, etc. So they can be creating so they can be having use cases around credit risk analysis. They would want to detect fraud using AI, customer analytics. So customer analytics is actually a broad topic which can be used in any industry, like retail, telco, can be used anywhere to understand customers. Like for example, you want to analyze your inventory that you have. Demand forecasting can be one use case. Personalized shopping experience can be used for your customers. In the telco industry, if you want to analyze which customer would be leaving them soon, they can do a churn prediction, customer churn prediction use case. In the healthcare, since there's many diseases coming up, you can actually use that data. You can use the patient's data to actually make a prediction whether the person has this disease or not. Heart failure is one example. There are multiple other examples as well. Transport, automotive, there are many such industries where you can implement different kinds of use cases in data using data science. So now that you have a good idea about what data science is, I wanted to discuss a few more concepts like MLOps, explainability. But before actually moving to these complicated topics like MLOps, and explainability, let's first dive deeper into the basic concepts of machine learning and some of the most common algorithms that are used. So machine learning is actually divided into two: supervised learning and unsupervised learning. I'm sure some of you might have heard of this. So supervised learning is when you have your data and it's actually labeled. You don't need to do anything. Like for example, if you're building a model for a bank and they want to do credit risk analysis, and you have data about the customer, the data along with the data of the customer, the data is already labeled whether this particular customer is a defaulter or not. And unsupervised learning, it's actually the opposite. So unsupervised learning is when the data set is unlabeled, and usually use clustering kind of algorithms to actually analyze these data sets and cluster them into different groups based on their points, based on the input that you have. So, and there's no human intervention into unsupervised learning. So supervised learning is actually divided into two. So there's one box missing here, which is for time series. So basically it's divided into classification and regression. So classification is when you want to classify, when you have a use case, when you want to classify into different classes, and this is actually when you want the output to be in discrete value. Regression is when you want to get a output that is in continuous value. Like for example, you want to predict the temperature. So the temperature would be a continuous value, right? So this is when regression is used. So just to explain classification and regression in more detail, so I'll just explain it using an example. So for classification, suppose that you're building spam and not spam kind of a model. You want to identify whether the emails coming in are spam or not. This is where you would be using classification, because the two outputs are actually divided into two, spam and not spam. Regression, on the other hand, let's say that you want to predict the price of a house. So the value that you're getting, the price, is a continuous value. So this is where regression is used. So moving on to MLOps. So has anyone here heard of MLOps before?
Not at all.
Okay. So you might have heard of DevOps maybe. So DevOps is actually where it's actually a set of practices in the software development and the IT operations department. So when you're actually building a software, building an application, to shorten the system development lifecycle, you actually use DevOps to continuously deliver these high quality software. It's used when you're building software in production, and you continuously have multiple deliverables to be delivered probably at the end of every month or quarter, etc., etc. And the same can be applied for machine learning. That's why the name MLOps, ML plus DevOps. So this is used when you're actually deploying your machine learning models into production. So so it's not possible when you have built a model, it's not possible to actually continuously using the same model every time without updating it ever in your entire lifetime. Why is that? It's so one of the number one reason is because data is constantly changing. And if your data is constantly changing, the model quality, the model accuracy would actually diminish. So, and there's actually a term for this called model drift. So the accuracy actually goes down in this case. And another reason for updating your model could be the business requirement. There is any change in the business requirement, or at some point you may even realize the data that you actually fed in, well, there was some bias in the data that you want to change. So this continuous cycle actually keeps on going, but data is the number one cause where you need to actually keep updating your model. So now to continuously update your model, you would require continuous integration with the application that is there. You would require continuous development as well. Hence, you would need the CI/CD pipelines that exist in DevOps to ensure that your model is actually being developed and deployed properly in this case. And this is where you can actually use Git, like as I mentioned, to help you with this process to um, develop and to do the experiment, as you can see on the slide: experiment, develop, and then put it into operation. And not to forget, these models, these machine learning models continuously need to be monitored. If there's any change in them, like if the accuracy has gone down, you need to continuously monitor them to update them accordingly. So if this topic actually interests you, I would recommend you to watch Andrew Ng's video, where he actually speaks about MLOps and specifically highlights why you need to move from model-centric to data-centric. This is something that I spoke about before as well, that data, cleansing your data and providing the right quality of data is very important. So we know, and you might have also heard of this, that a data scientist spends 80% of their time in preparing their data and 20% in actually training these models and building these models. But most of them actually focus a lot on this 20%, which actually takes a toll on their model accuracy, and they keep wondering that why is that the case. And even if you are right, and if you get the model accuracy right, you might want to say that, okay, I want to increase my model accuracy. So some people, what they do is that they increase the training data set, which is also right. You can increase the training data set, and it would increase the model accuracy, but it will only increase it by a little percentage. But at a certain stage, even that would be a constant line. It wouldn't really move ahead. It wouldn't really progress ahead, and it would just stay at one point. So what he says in this video is that instead of increasing your training data set, you should try to increase the quality of your data set. You should try to see how you can actually fix the data, and you would actually see your accuracy change drastically in this case. And MLOps is actually ensuring that you're actually providing the right kind of data, that you're actually providing high quality data to ensure this kind of accuracy of your model exists. So now I would be moving to explainable AI. So explainable AI, ethical AI is actually a vast topic, but I'll just try to summarize this using a example to make things brief. So we know that models are a black box, right? There's no way to figuring out how a certain model came up with this result. Like, for example, if you see in this example, we're trying to predict the price of a house. You have the training data, the algorithm, and you've gotten the output that, okay, hey, this is the price of your house. And the user is confused that, okay, if this is the price, like, why is this the price of the house? What are the particular reasons why it's priced so high or it's priced so low? So there's no way of figuring it out, right? So this is what explainable AI does. It solves this black box problem that exists right now, and it helps in decision making. So you have your training data, you have your algorithm, and now you've actually attached a explainable model and not the black box model. So this is so explainable. The explainable module actually uses something known as Lime libraries, or you can use there are other libraries that exist for including a explainable AI model. So right now you would get the output of the house, the price of the house, and it would explain to you what features actually led to this outcome. So, like, for example, it would say, okay, there were 5 bedrooms, that's why the price is so expensive. There is a good neighborhood, there's a garden, that's why this is the output that is there. So this black box uncertainty is actually removed once you have explainable AI into place. So that was the last topic for today. So before I end, I just wanted to give some concluding thoughts on how you can actually become a data scientist. So these are just some of my recommendation. Of course, there are plenty other things that you can try out. So what I would suggest is improving your programming skills, like learning either Python or R, trying to build expertise in one of them, and also focusing on an industry as well. Like, for example, if you're interested in the financial industry, you can try doing more research there, trying to see what kind of use cases are there, and trying to implement something basic out of it. Certifications do help as well. So you can actually look up some certifications on Coursera or Udemy to do that. And once you have your skills in place, you can start participating in different competitions. So this would actually help you with the hands-on part of things. So You can go to Kaggle, create an account, and start seeing what competitions are trending and start participating in them. Like if you don't want to participate them, you can actually look at what kind of problems are being solved by them and try to come up with a solution. You don't really have to submit your results if the competition is already closed. You can also get involved in the different communities that are there. They can be online communities or local communities. AstroLabs is one example. Women in data science is another. Women in data. There are so many different meetups, so many different conferences that are happening that are free to attend. So you can start attending those, start being a part of those, and start seeing what different people are doing in different industries. And at the end, you can also work on different data science projects. So you can always use Google and see what things are trending and start start applying your skills there. And then you can write blogs, you can write notebooks, and this would actually help improve your portfolio to then get a career in data science. And yeah, that actually ends my presentation. Thank you so much. And I think we can have a question and answer session now.
Thank you so much, Anshad. Thank you. I really appreciate it. It was really insightful. Thank you for sharing. Actually, just before we go into Q&A, I just wanted to share something. If you don't mind, stop sharing your screen. It's okay with you. Perfect. It's actually in line of what you were discussing of like where to learn. We actually at AstroLabs Academy, we do offer a data science and machine learning bootcamp. It's a 2-month course where we do cover the basics of data science and we start with Python programming. And then we go into building predictive modeling, and we cover the platforms such as Spark, Hadoop, and other platforms as well in data science. The goal of this course is to help anyone with no data or tech background to get an introduction into this world. Of course, it's not the last step, but at least it's the first step into the data world. And we actually have a data analysis and business intelligence course where it focuses on the other side of data, which is the business side of the sheets, the visualization, looking for insights, how to clean your data when it comes to in the business intelligence aspect. And we currently have an offer where you can get a 2,000 dirham discount on the data science and machine learning bootcamp. Plus, you will get the data analysis course with it bundled for free. Of course, on the slide, you can see my email, my number, where you can call or WhatsApp me. Feel free to reach out for us if you have any questions about the offer. And of course, if you have any questions about the session, please do so. I'm sure Ansha will be happy to help you.
Very nice. Thank you very much, Anchal. It was very informative. I have a question from my side. If we're talking about certifications, for example, you said we should just go to Udemy or Coursera, and do you mean just to finish that online courses there and get the certifications through online courses?
So there are many certifications that are there. I mean, if you start Googling, there will be like hundreds of certifications that are there. So what I would suggest is that if you see that, okay, I need to improve my basic Python skills, you can start with those courses. Like you could start with learning the basics of Python. So the certifications, what they would do is that they usually have a to Z kind of a course set up. So you know that you won't be missing anything. So that's why I would recommend like certifications or any courses to do. Like, so you can actually Google them according to the skill set that you require.
And my second question here, if we're talking about data science languages, so you mentioned Python and R. is it the only two, and it's just the most common two that are used in data science field, or is there anything that a real data science actually needs to know more than that?
So I've actually seen Python and R being used the most, and this is something that when you apply for jobs for data science, this is something that they would be asking you. They would be requiring Python, R, and SQL skills. So SQL is actually used a lot. So if you know SQL or no SQL, that is something that would be great. So I actually started by learning C++ from university, and then I quickly acquired Python skills as well. So yeah,
Thank you.
does that answer your question?
Yes, thanks.
There's another question as well.
Okay, I believe there's a question in the chat from Hisham. So he's asking us, like, for a career in cloud like Azure, AWS, or Google, is AutoML better because it seems a lot of job offers and big data is cloud-based at the moment?
So having cloud skills actually helps a lot. Cloud is also in demand. But if you I couldn't really recommend which one is better, Azure, AWS, or Google. But if you know either one of them, it would be great. I can't really recommend which one would be the best, because every job function has a different requirement, whether they're using Azure, AWS, or Google, like for even
Just
for big data.
also just some small insight on this topic as well. I was actually discussing it with Kate earlier today. So like you said, it's very accurate. Like, you cannot decide on which one is better. Maybe AWS has a slight advantage in front of the others, but the thing is, if you're looking at a career in Dubai, for example, or the Middle East, my personal advice is to focus on Microsoft Azure. The main reason for that is that there's a data center in the Middle East for those servers. So a lot of companies are actually using it. That's why there are like a lot of companies request Azure skills instead of AWS or Google Cloud. Doesn't mean it's better or worse. It's just because of like how it is in the Middle East. But they also recently AWS opened a data center in the Middle East. So I would be expecting job requirements for AWS skills in the next few months, or like the next year, I would say.
Yeah, agree with you there.
Right, I have a question. If someone were to start in the field of data science, like how would they start, for example, if they want to be more focused or to be a machine learning specialist or something? Do they have to start as a data scientist and then move forward, or how does it work?
So I've actually seen a lot of people taking jobs in as a business analyst or as a data analyst, and then slowly moving towards becoming a data scientist and then becoming a machine learning engineer. So first off, like they actually start by learning like programming skills, like as I said, like learning about Python, because that is something that is being asked by everyone. So that is like the starting point initially. Like once you have those Python skills, the next thing that I would recommend is actually working on some projects that you can actually mention on your CV, and you can actually build up stories when you're like interviewing.
Okay, thank you.
When
Also-
we're creating, sorry, Amar.
Yes, I just like about the same topic. That's why it's like, correct me if I'm wrong, but like so a lot of people are sometimes scared to start learning Python because they always hear about C++ or C# or Java, and they think they need to know a background. I personally, knowing C++ was hell for me, and moving from C++ to Python made me realize how easy and simple Python is. And not for everyone, but sometimes actually having a background in a different programming language that use different approach in programming the shift might be difficult to Python. So actually starting fresh with Python can actually be an advantage for those who don't have a technical background.
Yeah, I agree with you. Like I started off with C++ as well, and then learning Python was just a piece of cake.
I can agree with you 100% because I also started with C++ and then on Python, and it's just really very, very easy. So I also have a question in regards to making a portfolio, right? So you just want to make different projects. How do you actually make a portfolio? Maybe there are any tips where you can just host your code or present it to show through your CV, like what's your tips on that?
So there are multiple ways to do that. So yes, mentioning like creating a project, like working on it and then mentioning it on your CV is one. People also have GitHub accounts and they have repositories over there for their projects. So if someone were to look at their GitHub, they would see, okay, this person worked on so-and-so project and they use so-and-so code. So that is another one. Third, I've also seen people hosting their own websites. So they actually have their own portfolio set up like as their own website. So if they were to give, if someone asked for their CV, they would just go ahead and give their website that, hey, you can go look at my website. These are the things that I have done. And so I also have a Medium page where I actually write blogs. So that can also be counted as one of your portfolio. So you can do all of them basically. People do all of them together. There's no one thing that you need to do. You can do all of them. You can have your CV, website, GitHub. You can have your blogs. You can set up everything. So yeah.
All right, thank you very much. How can we find you on Medium and how can we find you on GitHub?
So I was actually sharing my screen. Can I share my screen?
Yeah, sure, of course. Sorry.
Yeah, so you can find me here. You can find me on Twitter, LinkedIn, Medium.
All right. Do you have anything on GitHub as well?
Yes, I do. It's I'll just type it in. This is my
in the chat,
GitHub.
maybe.
Yeah.
Amazing, thank you.
Let me just stop sharing. I'll just share the link.
Guys, do we have any other questions to Anchal?
Okay, thank you for sharing, Anshal.
Thank you.
So much.
Maybe just one final question from my side, Abdullah Al-Qasmi here. I'm new to the field here in data science, and I see it quite interesting and growing rapidly here in the market. I mean, I would understand more if it's possible if you've been exposed to, for example, data science in the corporate side or data science in terms of entrepreneurs or small businesses and startups. Which direction would be more useful, beneficial, or I would say more challenging, if you will?
That's a very good question. So I have actually been exposed to the corporate data science only.
Mhm.
So I cannot really comment on how it goes in startups. But from what I see is that, and from what I hear actually, is that in startups, there's like a lot of flexibility in terms of the timeline. Like, for example, there's a lot of things are going very quickly in startups where they are requesting you to publish new models every, I don't know, every week or every month. Like, I've been hearing that a lot. In corporates, there are certain rules and policies that you actually need to follow before you like actually publish something. There is a whole like a management kind of a, not management, like there's a whole line of people that you need to request something to be done. So I cannot really comment on like I haven't experienced the startup side, so I can't really distinguish between both of them.
Yeah, maybe what I even mean by startups, would it be possible to work on data science projects by yourself and then presenting it to someone rather than just being as a data scientist in a corporate? Or could they work hand in hand? I mean, if you go and do some certain projects by yourself and present them to, let's say, for example, a small or medium business, would that be an option you would pursue?
Oh, okay. Yes, yes. So yeah, so there are data scientists who just really just work on the like just coding side of things, and they don't really do presentations to different stakeholders. So that is like a purely technical role. And then there are ones who just like citizen data scientists, you can say, who just work on like let's say like a POC or like a small MVP kind of a project, and then they actually present it to different stakeholders. So I think if you look at the a technical, like a person who is working in technical sales, that is something that they do a lot. They do a lot of presentations. They do half presentations, half building models. So both of these kind of jobs actually exist, and you can also be someone who just gives presentations as well. So yeah, there is like an in-between, if that's
Yeah.
what you were asking.
Thank you so much.
So does that answer your question?
Yes, thank you.
Okay, perfect. I think there's no more questions. Anyways, like I see that you put your details here. If you guys feel free to contact us at AstroLabs or Anchal if you have any questions. Anchal, it was a pleasure having you. Thank you so much for the insights. Thank you so much for everything you shared. And hopefully we'll meet again soon.
Thank you so much for having me.
Thank you,
Thank
everyone.
you. Thank you, everyone.